Hello, Ashley, can you hear me?
I can, yes, hello.
Okay, hello. So is it the right room? I hope.
Everything looks good.
Very well.
I'll just be sitting in the session to watch for any code of conduct issues, or if anyone has any questions, then I can help out.
All right, very good.
Hi, Ashley. Hi, Pavel.
No, I can hear you well.
Hello.
Very good.
Hello. It's a bit dark here. Ashley, we're going to present from Google Slides. I'm not sure if Pavel already mentioned. That shouldn't be a problem, right?
He did not mention that. That should be fine. If there's any issues, I can always call for support to help you out.
But basically, we just share our screen and it can be anything. And yeah, okay, good.
Yeah. Yep.
Okay. And
yeah,
we also...
I saw the options. You can also present one particular Chrome tab.
Ah, okay, cool. The other thing is we're gonna have 3 presenters, so we're gonna switch sometime between presenters. Is it something we need to consider there, or?
I don't think so. Just it's a lot like Zoom meetings, and just sharing your screen. Anyone can go on, start talking at any time. If you're going to be screen sharing and switching talkers, it might be hard for people to minimize screens to be able to see the screen that was being shared, or, I don't know if people will change the look of their screens. So it should be fine though.
And I will be going to the code, presenting my Visual Studio code for some time, but I hope it also doesn't introduce any problems. I made sure that the font is big enough to be read.
Okay, great.
So we're just trying to point our third presenter to this room. I can just give him the workshop URL we have in our browser here, right?
Yes, that should work if you just share the URL.
Okay. So Ashley, just to let you know, so Adrian has some technical problems to dial into the backroom stage here, the backstage. So, but he has said that some technical people already said they're gonna help him to fix it. I know it works, he says. Okay, good. Okay, hey Adrian.
Hi. Hello, everyone. So we're going to wait another 2 to 3 minutes before we start.
Maybe you could answer the question of Andrew and Rada, if the session is be available later.
So it's being recorded. I think it will make it available. Do you know Daniel, or do you know Paul?
Maybe Ashley can confirm, but I would guess it will be available later. Yes.
Okay, cool. Thank you.
I mean, the one from last year was available.
Yeah. Our interest is definitely that it will be available. Yes.
Good. Yes, if you have any question, please write it in the chat, and we're trying to answer those. Are we good, Ashley, or Daniel? I think, how many people did sign up? 100 people now around. I think, should we start?
I think we can slowly start. Yes.
Good. So welcome everyone to our tutorial in lesson for designing scalable and maintainable Shiny apps. So Pavel, myself, and Daniel are going to present today on lessons we have learned on working mainly on a fairly big framework for creating interactive data analysis apps in Shiny. And so we thought it would be helpful to share some of our experience. So, quick round of introduction. My name is Adrian Waddell. I've been working for Roche for 6 years, and then recently I've moved to Genentech into research. But while working at Roche, I have been working on creating R tools for clinical trial analysis, and some of those were exploratory, some of those are regulatory for submitting clinical trial data analysis results to the health authorities. And so many of the lessons that we present here have been gained during that time. And in fact, we're going to make an example Shiny app that we show from that work. Good, maybe Daniel next.
Yeah, welcome everyone. Also from my side here, Dani Zabanes. I'm a statistician by training, and I'm currently leading the statistical engineering team in Roche, product development, data sciences, where we kind of work at the intersection between biostatistics and software engineering. And yeah, I've been working with Adrian and Pavel in the last years, and I thought it would be great that we can share a little bit on our tips and tricks for really producing production-grade Shiny apps with you. And yeah, so that's kind of the tutorial today. So looking forward to it. Thanks. Pavel?
Hello, my name is Paweł Rudzki. I'm econometrician by background. I joined Roche almost more than 3 years ago now. And right now I'm in the role of being a chief engineer for the project, leading some engineering team leads about the vision, about the implementation of the things that we need to do. I joined the Nest project from the very beginning, working together with Adrian and Daniel. And yeah, I basically echo what guys have said. This is for you. to share our experiences, our lessons, what we think it's considered it's relevant throughout the whole process of designing those tools. So looking forward.
Good, thank you, Pavel. So good. So the tutorial objectives. So the tutorial is formed in a way that we spend most of the time talking. We have code that we can share at the end. But yeah, it's essentially a long lesson. We give code to try it at home, but not during the tutorial. And so what we will go over is different aspects of creating larger, maintainable, scalable, Shiny apps. And that includes how do you design it, like how do you plan it, what are the considerations when you design a fairly big Shiny app, how do you use modules, how do you make the modules configurable for different use cases for reuse, how do you manage your reactivity graph, like tips on keeping it simple and understandable. We have some tips on using object-oriented programming with R6 classes. And then we end the tutorial in talking about deployment, like wrapping the package in packages and testing. So it's tended to be an end-to-end tutorial on various aspects of the development process. Good. So the 5 sections are introduction, like design the solution, mastering the implementation, packing the product, and then we wrap up with a summary with conclusions. Good. And so I'm going to start with the motivation. So generally, when you start the Shiny app, building a Shiny app, that is intended to be longer used in the company and by multiple, like co-developed by multiple people, then there are certain considerations that you should look into before you roll it out and when you plan it. And so one example we have from our side was the Teal Framework, which I've presented previously at USAR, which is a fairly big Shiny layer. It's in fact a framework where you can create Shiny apps fairly quickly. You can configure your Shiny apps, and then I'm going to make a presentation. I think that is not to say it's a Teal presentation here, but we think it's a good example. It's useful for it's a useful example for this presentation. But the tips are generic to any big Shiny app or also small. Also good is that Teal is open sourced, is now open sourced. You can find it at github.com/insightsengineering/Teal. So you can actually go and look some of the things, try it yourself with the framework and see how we have implemented it. Yes, so we focus on design, implementation, testing, as mentioned before, and we give code examples that you then can try at home. So last year I gave a talk on all of our tools we create, or most of the tools we create for clinical trials with R, which is both for static output generation and for interactive web apps. And you can see the video recording here. I would like to make a short recap, and that's a graphic that is available from that last presentation. That when you design an analytics environment, it's important to keep those 3 endpoints in mind and not just focus on one. And I think the one for reviewing statics output is very clean, like pharma clinical trial specific, but the other 2 are fairly general. So one is you want to write outputs on PDFs or like PDFs usually, so that people can review it. You see there's like title footnotes to put the output actually into context. That is used for a in clinical trials for like downstream medical writers and so on. But essentially it's a printout on a paper. Then there is the exploratory web application, where Shiny excels at. And that's what we're going to be talking mainly today. But then also very important is that whatever tools you write, you can also use them in R Markdown on the command line with any data. But yeah, so for today, we're going to focus on the Shiny apps. And so I'm going to give a short presentation of the Teal framework. It's really more to show that we have created a fairly big Shiny app. You can use it. And then when we give the examples, as mentioned before, it's quite generic to other Shiny apps as well. But Teal is a Shiny framework to let lots of analysts create like their own Shiny apps very efficiently to do standard data analytics tasks. It has a filter panel to dynamically subset the data. Then it has usually on the left-hand side, and that depends on the modules that you use, analysis modules. It has ways to encode the output that you're interested in, and the output might be like a table with columns and rows. It might be model summaries, or it may be just raw data or a visualization. Teal has one feature that I think then Joe Chang has also worked on that, which is the show R code functionality, where when you see an output at the center of your screen and the module supports it, you can click on that show R code button. It tells you exactly how the data was loaded, how it was subsetted with the filter panel, and what encodings have been used, and then how to recreate the code. So you can essentially run the code to get exactly the same output. By now, it has functionality to create reports in general, like longer reports. And we have quite a bit of features to load the data from different data sources. And the tricky part here was to make it such that it allows for authentication. And then I think one part that we spent quite a bit of time on working was that make Teal work with different data models. So we have relational data, but we also allow for biomarker data, which has quite a bit of different shape. And that we allow the filtering and the analysis of. Good. So I'm giving a short demonstration. Again, I have a more in-depth presentation, both in an RStudio webinar and in last year's user talk. And so one important piece here is whatever data you see here has nothing to do with patient data. It's all randomly generated. It's essentially synthetic data. And so if you start the Teal app, you usually get access to the raw data. You can add and remove. Variables. And so here we have 4 data sets. We have a subject level data set. We have questionnaire, time to event, and response data set. And I think for those of you who are not informed, it doesn't matter that much for the context of this talk. On the right-hand side, we have the filter panel. So we know we have those 4 data sets. You can then use, for example, say I would like to filter the data so it shows actually the distribution. I would like to see all the patients that are between 35 and 46, and then it tells you, because those are relational data set, how that propagates to the other data sets, like that condition. So essentially, ADSL filters also the questionnaire, the time to event, and the response data set. And so next to raw data table, we also have a variable browser that just standard generic things, modules to quick given information, what kind of data do you have hand. I think what's unique, or not unique, but it's very common in clinical trial analysis that the variables also have labels, and dplyr supports those labels, RStudio supports those labels, like the RStudio data viewer. And so we here also show them variable name, variable label, and then a quick visualization. If you click on those, there's some more extended visualization. And then the last thing are the analysis modules, where you, again, here's the filtering, here's the encoding. So here you can select how that table, what are the encodings of the table. So you can change the ARM variable, or you can say, I would like to add the country of the patients. And it updates dynamically. You change this. The filtering, it updates dynamically because the demographics table is only using the ADSL data set. We do remove the other data sets from the view because they're not relevant for that output. And you can keep adding gender, remove it, and it keeps updating. And as mentioned before, it has that code reproducibility. So when you click on show R code, it's generating the R code, it predifies it, and here you see the well. So here it's random data, but you see the subsetting that we've done interactively in a minimal way, and then you see a couple of things with variable labels. But in the end, you have the basic table summarized, and that creates your demographics table. And so if you copy that to the clipboard, it can go into an RStudio session with those packages installed, and can recreate exactly this output. Yes, so that's a very short rundown of Teal. We also support plots and various nice features to work with. Different types of outputs and subsetting. Good. So that Shiny app was, I think, the beginning for us to start transitioning, like for Roche clinical trials, to start transitioning lots of analytics work, like program analytics works from SAS to R. So Shiny was really a great way to show the value of we can do now something that was very difficult to do without R and Shiny. And during the years, which is now around, I think, 4 years, within 4 years, the space really has changed quite a bit. I'm trying to keep it here general, not pharma specific. But before most of the programming, the data analysis programming, was done in a proprietary software, SAS, for those who know SAS. Now it's done both in proprietary software and R, including Teal, Shiny, and we have like Rs Connect servers, and we have RStudio, Workbench. I think a much more environment that young data scientist talents appreciate. And that's the next point. Before, people would come with R skills, and they had little knowledge of the other, like of SAS in that case. Now, and so there was very little work, R actually available. And now, using R and using Teal is recommended as part of the analysis plan, which again, it's good. So actually, you don't, like, there's a way to use the language and to add value to the product. Then before, there were many, so that's Teal specific. Before, there were lots of some big Shiny apps where you had to upload your data and had to do all the linking. With that Teal framework, it has changed a lot towards like this big Shiny app to it's very easy to now create many small T-labs that are study specific, where you essentially have no setup cost from a user. So there's one person who sets it up, but the user then loads the app and can immediately start looking at the data. And also, like 5 years ago or 4 years ago, the R environments were much sparser. Now we have various environments that range from exploratory, like non-validated and validated environments. Yeah, so it really has changed a lot in the last couple of years. The use of R in health, like in pharma, for analyzing clinical trial data. That's important. As pharma is big, but for the clinical trial data analysis, yes, it really has evolved a lot towards the use of R. Good. I hope that gave a good motivation or at least an overview of what we have been working on and what the impact was. And so we will now move on to talk about what have we learned, what do we recommend to take forward, like lessons learned essentially. And that is designing the solution, mastering the implementation, and packaging the product, as mentioned before. Good. I hand over to Pavel. Thanks.
All right, so let me take over the screen. Maybe that would be more convenient. So Adrian, I guess you need to quit and then I will take over from you then.
I wonder how do I quit, but share options. Can I stop sharing? Here, stop presenting. Thank you.
Very well. All right. Can you see my screen now?
Yes.
Yes.
Yes, good. I'm on the single screen, so please tell me if something will be broken. Okay. So yeah, let me then go into the designing solution. So Adrian built a nice story about what was like a very quick summary of what has been achieved like during these 4 years of our journey. So let me go back from the very beginning into the design phase and how we achieved that. What were the steps that we have made? What were the decisions that we have made? What are the pros and what are the cons? So let's switch on the time machine, go back in time and go into the designing the solution. So the very first, let's say, let me go back into the so-called user story. User story is a nice way to expressing the problems. And this is very well known in the programming. So this is built as a, let's say, it has 3 main parts in it. So as a role, in order to do something, I need something. So here the problem was as follows. As a data scientist, in order to perform and do the data analysis in the interactive way, non-static, because the static has been already covered by existing SaaS solutions. They wanted to somehow have the interactive layer on the top of it. They need some kind of app, a solution that will address that so that they can access their data sets, one or many, and create the outputs in form of tabulations and visualizations that Adrian presented. So that was the problem that we were facing from the very beginning. Let's then...
Second, can
Yep.
you go on full screen presentation mode, please? So it's easier to see for participants.
Yep.
Thanks.
Let me go to this. Oh, yep. Is it better now?
Yeah, that's
Yes,
good.
thanks.
Okay, so let me then, so we rephrased trying to refine that problem even more, and this is the tool that I would recommend to you. This is so-called 5 Ws, which are the questions who, what, when, where, and why. So who, are looking for the problem. Those are the data scientists, statisticians, subject matter experts, internally, for now at least. What they wanted an application to to present the visualization on the data in some kind of views, different views in form of tables or graphs. Why? Because they wanted to switch from static into interactive way of doing that analysis, where most likely as a web application available in some internal system so that I can access this on Chrome or whatever and do the analysis in there. When, of course, as soon as possible. So those were the questions that we are facing. And after many, many discussions, we proposed the following. So we decided to present or to release and to create and then give it to the users some sort of suite of tools to create the apps on their own. So we proposed to create few packages at the very beginning, enabling our end users to create their custom fit for purpose apps that meet some specific requirements. And in particular, that was not so-called mega app that does everything and trying to address all the needs that we were facing, because we identified that there are some different stakeholder groups that might have different needs, and it's impossible to address all of them at once. Therefore, we create the tools, meaning that please take it from us and do the apps by yourself. This has many advantages over this mega app approach. In particular, it allows more flexibility because those people will create the apps that they actually need. So there might be some outputs that the stakeholder group might not be interested of, and it's better for them to create what they actually want, and it will be easier to navigate and so on and so forth. It has this scalability feature that we might have n apps as opposed to one mega app, so it can scale horizontally on many applications that were living in our systems. Compared to this mega app approach, it has the ease of configuration and customization and navigation. It's much more easier to navigate on the app that has, I don't know, 5 modules, 5 outputs compared to 55, where I'm interested in those 5 only, right? When packaged as an R package, it has also some advantages over the code maintenance, the release cycle, the product release cycle, and so on and so forth. So the chart on the right presented a typical workflow that we were anticipating, that there will be many study teams creating their own apps for their own needs. So there is a role of app developer collecting and creating the code, the application code that is being pushed into the RStudio Connect. And then at the end of the day, those are app users that are essentially using the app and draw the conclusions out of the outputs. In the middle, there is a module developer, so a particular, let's say, part of the app creator. And we were foreseeing that there will be some general module developer, that is the guy in the middle, that will create some modules that of general use that might or might not be used by the app developers. But there is also some custom module developers if they see that something is missing, so it is possible to create their own type of the visualization. So this is what we proposed, and this is what was generally accepted. And continuing the story of proposed solution, so you have to also try to answer one key question of know your customer. Who are the stakeholders that you will be facing? So we are foreseeing that there will be 3 stakeholders for us. The first one, as I said, though, this is an app developer. We thought that it will be an R programmer or analyst with some kind of R skills. And the main responsibility is to create an app code and maintain it, of course, for some future modifications. And this code needs to be pushed to the server for the users to use. There is a module developer that is also an R programmer that is responsible of creating some code. We call it modules, and I will be using those terms throughout this presentation. By modules, I mean some part of some small encapsulated part of the app to be used by the app developers. And as I said on the previous chart, there might be some general module developers as well as specific module developers. And the third actor here is the app user, probably the most important, because this actually assess the app and give the feedback that this is good or this is not good. So this is the user of the app, user of the module that interactively creates the visualization on the fly, interpret it, and draw some conclusions out of it. So those were the three stakeholders types that we were facing to deal with. Who does what? So module developer creates some kind of functions, essentially a functions, module A and B and C, give appropriate arguments. So this is also relevant to give a nice public interface of that model, and I will be talking about that more soon. And also being responsible of the body of that function, which is what goes into this as an internal, what are the reactivity, shiny reactivity management, as well as business logic management. And then app developer creates the final code of the app. But I would like to also draw your attention into these three dots on actually each of the three dots here. So for the module developers, three dots that are super relevant. This is public interface of the function, and of course the body of the function. And for the app developer, it is essential to give the modules appropriate arguments. For some of the modules, it could be repeated. Therefore, it is important to efficiently manage the objects throughout the script, because the app is a script essentially, or we assume that it's gonna be a script. And the second part that app developer is responsible of is to create the data inputs. In the very basic form, this is a list of the data sets if they are already available in the R session at the moment that we create the app, or we create some sort of, we call it connectors, so provide the connection details to the databases so that we can authenticate and pull the data from that source. And the last command is, of course, run app for the server to understand that it needs to execute the application. So this is a very basic split of the roles. And as I said, it's super relevant to understand who is responsible of what. And each of this role has some very significant, very prominent responsibilities, and they need to talk to each other. So for instance, module developer needs to assure that his modules would be easy to be used by the app developers. Okay, so then we go into the design of the application, and I'm gonna start with the data flow. So our recommendation is to keep it simple. So in the application, we have two big, let's say, parts. One is the data, and the second is module. The data is a collection of so-called data sets. Small, let's say, it could be considered as a table, for instance, iris and empty cars. And this data needs to be accessed by the modules it is many-to-one relation. So one model can use multiple data sets, or in particular, in some extreme case, one model is using one data set only. Technically, it would be possible to create a model without the data set for for instance, some kind of home screen in the application. In particular, we do not allow modules to talk to each other. So an output of one module would be input for another module. And also we block some kind of circling back to the data instance, so module to modify the data. You might find it pretty restrictive, but this assure some kind of stability of the system, because my recommendation, so we are talking about the base layer only, and my recommendation is to keep the base layer as simple as possible, because then if you put a lot of complex logic into the base, then the base would be hard to understand, hard to follow, and then there will be some challenges, technical challenges for the app developer and for the module developer. So the base needs to be simple to be then efficiently used by the by our actors, app developer and module developer. All the, let's say, complicated, complex part, I would say it's put it inside the module. So if you wanted to tweak some data using your specific business logic, that needs to be put it inside the module. But the base needs to be very simple to be efficiently used by the actors. Then second part is the user interface layer. This is what we propose. You might saw this on Adrian's demo. So basically, we split the interface into two parts. One is module panel on the left, that is almost like 2/3 of the width, and the rest is consumed by the filter panel. Filter panel is something that might be specific for the clinical trial environment that we are facing. And the reason behind the filter panel is that we saw that the end users, our end analysts, are interested in some kind of subpopulation analysis. So for as an example, they wanted to set the filter criteria on some flag, that the flag is equal to true, and they wanted this to be respected by all the modules, right? So as a very first action, or it can be even preset on the app call, call step, that they are pre-filter the data sets and then run all of the modules. So you might see this like let's conduct the demographic table for the patient with some particular disease identified by some flag. Those filters, as I said, are shared across the modules. So all the modules respect the central data. So this is in line with the data flow that I presented. So all the filter will go to the left and will modify the data. On the left, on the central part, this is a module panel, and module panel is divided into two. Further divided into two. Left side is so-called module encoding. So here goes all the configurations, and the central part, the overall central part, is consumed by the main panel, which is the main visualization. So on the right, you are selecting the filter to conduct the subgroup population analysis. On the left, you submit your specific module setting, and this goes both into the main panel to produce the output in form of table or a graph. And at the top, we have this horizontal bar of multiple modules. And this is an example. So on the right-hand side, we've got the filter panel to filter by age and sex. you can dynamically add the filter variables of multiple data sets. On the left-hand side, those goes module-specific configurations and codings. This is, for instance, choosing the X variable, choosing Y variable, choosing color by and size by, also some ggplot theme, and so on and so forth, which is an input for the main panel to produce an output. This also, in between the lines, the message that we are sending to you is that each of the module is responsible of creating one output, one visualization. We thought, and it is actually much more easier to configure by the end users, as opposed to have multiple visualizations that are dependent on each other. So simplicity is your friend, at least, especially for the beginning. Then each of the, let's say, module, specific module could be further enhanced, but you need to start with the basic. Then going into the module, what goes into there? One important piece is that we wanted to split the business logic from the shiny reactive programming. We even established some kind of role of statistical engineer, and from the module developer, from the role of module developer, that the module developer is essentially being responsible of the shiny reactivity programming, and the statistical engineer provides some functions to be called then by the module developers with the arguments that are most likely coming from the user interface. Going into the code, and I hope it is readable for you. So an example, if we split the business logic into the functions, we might have the calculation function, and with some arguments and some function body, as well as the plot. So this is super business specific, what goes into calc and what goes into plotting. And then module developer creating this all well-known module server, UI and server part, and call the functions that are being defined outside of the module. Even better, if we split the business logic into the separate package, then this code needs just a little of modification to have this package prefix and the function call. This has number of advantages. First of all, one big advantage is that this follows single responsibility principle. So my previous function, this calc and plot, are being responsible of doing the calculation and creating a particular plot. If you split the logic into small and encapsulated parts, it's better to maintain this, because you can test it. There is a clear logic split, and it's easier to navigate, easier to onboard new people into that workflow. Then this is much more easier to trace and debug. So for instance, if you have the error messages or base error messages, it's being reported that my calc function fails, as opposed to shiny saying that this particular observe fails. This is relevant for testing, and yeah, this is actually super critical for unit testing. Testability, as I said, one important caveat about the testability is that quite often, we have found that quite often business logic functions depends on the data. Let's surprise, surprise. But this setup allows to test the business logic functions if they are separated into separate objects on different data sets, as opposed to running the overall, the big app on multiple test sets. This is much more efficient for the sake of your internal CI environment and auto-testing as a whole. More accurate test results, I have just mentioned this. Reusability, this is important. And Adrian mentioned this, but let me underline that. In our case, it was relevant that our functionals are executed in the regulatory environment, which does not support Shiny as a whole. So at the end of the day, each of the analysts needs to have R code as a script to be executed by some orchestration engine or whatever it's called. But in particular outside of the Shiny thing. So we have this requirement. So that's partially the main driver of that split, but this has other pros. Yeah, from different sources, and actually you never know when it's gonna happen if you publish your work internally. Better file structure management. That's also pretty obvious if separated into the packages. So if you split your business logic into a separate package doing your calculations and the other package doing the Shiny work, Shiny related stuff, then it's easier to manage your dependency, because the latter will require Shiny and all the, let's say, graphical user interface packages such as Shiny dashboards, Shiny JS, or whatever, whereas the former, the stats package requires the statistical packages. And you might find throughout your lifecycle management of the packages that you might want to update, for instance, the Shiny one. You find the cool package, cool user interface to increase the user experience. And you wanted to put that feature, that enhancement into your code base, and then release that for the users. So if you have everything grouped into single package, then you have to release everything, and as opposed to releasing only Shiny related package. This is relevant because, for instance, our users, the statistical engineer or subject matter experts, are not that willing to update the stats package because they are sort of validated. They know that they give a correct results, and they are not willing to update because they might consider this as a danger for the study work, and they need to recheck once again all the outputs. For them, the message that we are sending, that we are releasing only enhancing the user interface, therefore you can still keep your stats package as you like, but feel free to upgrade into the Shiny the package responsible of Shiny interactive layer. That was relevant, and also that split helps on that front. Yeah, so this is what I have just said. But it has one big prominent drawback, which means that it requires some integration tests. Integration tests are the tests to check how each of the components talk to each other. So if the modifications in one does not break the other one. So for instance, if we modify the stats package to change some requirements, to rename some of the arguments, this might break the interactive layer if we would name the call, if we would name the argument in the code that we are parsing in the module. So this is difficult to achieve, and we will be giving some hints how to do that in the later part. Yes, precisely. Then goes how to define the module, and this is some kind of low-level tips of how to define the function. Like this could be generalized into our tips how to define the functions. The questions to be asked, and that is super relevant. This is what I was trying to underline in the responsibilities part. Those are what should be configurable, because sometimes, actually almost always, you have to preset some of the arguments, and you might find that, oh, I wanted to configure this. I wanted to configure font size, for instance. So then okay, so I need to expose one additional argument. How to avoid that? What arguments should be exposed to the app developers? How to organize the arguments if you end up with adding one, adding two, blah blah blah, and you might end up with having 20 arguments. This is a bad practice in general. And in general, the fourth point: how to write good, clean, and maintainable code. So those goes our hints. So first of all, use the arguments in the right order. So for instance, in our models, we have X and Y sort of, data specifications, how to, let's say, influencing the user interface, which are in particular from which columns users choose the X and Y. Same for color by. Then we have title, subtitle, so it's natural to keep it all together. A legend, true, false, or some additional arguments going into there, and some arbitrarily horizontal and vertical lines, and so on and so forth. So it's important to keep the business logic in there, to keep it logically reasonable. I mean the order of those. The next thing that we have identified after a couple of months of developing and adding yet another features to our model is to avoid dependencies between the arguments. So let's assume we have a horizontal line. So this is what are the attributes of that line? Those are value, this is color, this is label, this is blah, blah, blah. So if we keep adding this more and more, we have identified that some of our models grow significantly. I mean, the interface of the function, and it's difficult even for our internal development teams to navigate, to maintain that code. And our advice is to use so-called parameter object pattern to group everything together. It could be named, I don't know, specifications, line specifications, and it's relevant to keep it open. I mean, this could be a constructor of the object that could take like any argument and put it into some kind of list to be then parsed inside the model and used to produce the visualization. Consistent naming convention. So this is somehow related to the order on my first slide. So this is pretty simple, pretty obvious. H line, V line stands for horizontal line and vertical line. I cannot, let's say, foresee any different names, such as horis underscore line, and the second one would be V underscore line. You need to avoid that. The next one is something that really annoys me as a developer reviewing the pull request, is that some people tend to have ambiguous class of the arguments. In particular, I see in the Roxygen example that a given argument can take true, false, or being a character, or being a character vector, or being, I don't know, list of the characters. You need to avoid that and to keep the class very strict. So in order to, for instance, give the message or send the message about I don't want the title, so then you just put the empty character as a value of that argument. So my recommendation is to avoid that practice in general. Another Another thing that I recently find pretty useful is that required arguments shouldn't have the defaults, and we need to enumerate all possible values in the argument values, in the default argument values, and then make use of the so-called match arg functions inside the body. So here, if I will be seeing that function in the help manual, I know that I need to provide X and Y and color by, and I can left all the other empty. And please note the object object pattern of the line spec without any arguments. This is also a default, meaning that this empty constructor, this is so-called another null object pattern of saying that I don't want this to be provided. Another hint from us is to use the defensive programming via assertions. The well-known package is assert.dat to check the argument values. We have identified not so long time ago the checkmate, another cool package to do the assertions. And this needs to happen at the very beginning of the function, so that then the function body can assume that the argument is of given type, and you won't be surprised, for instance, by the length of the value. Another type is that maybe not one single function in particular. This is about the multiple functions is to know the use case, basically how your functions are being executed. This is something that we discovered quite recently, is that we made use of the R option as a default. So then it is much more easier for the app developers to modify the function arguments by one call only. So in general, the app developers made use of multiple modules, right? And in order to preserve as an example, in order to preserve some kind of consistent color palette throughout the visualization, there is one call needed to set the option, and then that option would be used by the default arguments of the color argument here. Another one, very quickly, is to avoid so-called code smells. Code smells are some kind of, the definition for it is that the code is working correctly, giving the right outputs, but something is stinky here, and you might find that you will dislike a given code. A few examples of the categories of the so-called code smells are the bloaters. Bloaters is the code that throughout the life cycle of that function, of that object, it increases to that size that is very difficult to cope with. And a great example is a large functions or the long parameter list. And here I gave you some hint how to avoid that. Object orientation abusers are the incomplete or incorrect applications of the object-oriented principles, such as switch statement or of the two or actually many functionalities responsible of the same thing, but with the different interfaces. Change preventers are the codes or are the situations or the codes that makes introducing change in one place. You have to do this in multiple places, so it's very hard to address some new feature requirements. Dispensables. This is something unneeded whose absence would be much more efficient or easy to understand, such as dead code, commented out code, or non-necessarily or super obvious comments to the code, like inside the code base. Couples, this is something that I'm trying to avoid a lot, is that extensive coupling between the functionalities. This is somehow connected with the change preventers. This is the source. If you will be having this this presentation, feel free to go into the design pattern and the website to see the definition and the examples and how to avoid that. Two last hints is to use solid. Solid is some principles that are applied especially in the object-oriented programming, but to me, not only. This should be followed like even without following the OOP. And the part that I would like to highlight for the sake of the maintenance, the scalability, is the O part, is that your software needs to be open for an extension, but closed for a modification. So for instance, if you wanted to have, I don't know, a legend, you provide another argument to that function and you don't have to modify the function body to address your need. And the second one is Yagni, you aren't gonna need it. So you need to always answer your question when submitting the pull request or assessing the other pull request, if it's really going to be needed or required or used. Sometimes development teams, the developers wanted to show off their skills, especially the new one. And they produce a lot of code, a super cool feature, but it's not necessarily required. So you have to always be very minimalistic, very simple, very to the point, and not overcomplicate a simple task. Precisely. So this is our tool. So those are the hints, and this is the tools that we have created. In the central part, this is a Teal package, an umbrella package, to have the Teal modules. This is the second layer. And Teal modules are interactive layer on the business logic in the top one, in the calculations. Then there are some functionals that are used throughout the Teal modules. So we decided to split it and introduce the third line on the chart for the modules and also for the core Teal. And at the bottom there is some utils Teal logger. So this is the coupling business logic from the Shiny layer. This is so-called Turn package that has Teal modules clinical interactive layer. This is Osprey that has Teal Osprey. This is Goshak that has Teal Goshak. This is object pattern. So we saw that some of the modules has some shared logic between them, and in order to create those objects, we separate this into the separate package to create with the object constructors. And this is a decoupling functionals for the better lifecycle management and dependency management. So to wrap up my section, a short summary. So first of all, know the business context and know your customer. So the business context is that, as Adrian outlined, this is a general switch from towards the open source technologies such as R, and this helps us a lot to succeed because we have a lot of management support with our development activities. Know your customers is to identify the key roles that you will be facing, and this is relevant for the designing solutions. You have to make some reasonable assumptions, especially when it comes to the technical skills, not to require too much from some people, because at the end of the day, our customers are analysts who draw the conclusions, and they don't want to create some super complex data structures. They wanted to spin up the app, put the data into this and draw the conclusions. That's the goal. So we need to have some simple interfaces. It needs to be very easy and convenient to use. The decision of the problem that we are facing is to create a suite of tools, R packages, but not only, to create the fit-for-purpose applications. And our users are analysts who can cope with the R code, who can write the app code by themselves. This has a number of advantages: scalability, horizontal scaling. If you have the app, you achieve horizontal scaling via modules. You can create as many modules into your app as you can. And the vertical scaling is through the module customization using different patterns, such as object patterns, such as null object, etc., and so on and so forth. Maintainability. Storing your code as an R package has a number of advantages, including it is actually the best way of code management. It has a user documentation layer and more, and Daniel will cover this part later on. When designing the tools, this overall suite, it's super important to keep the split between business logic and application codes for the dependency management and the release cycle management. And my final advice is to make sure to write a good and, more importantly, clean code, especially for the public interfaces of your package. And I'm giving you further materials. The first one is Tidyverse Design Guide. This is not very well advertised, but this is super useful for learning how to write the code. There is a great open source book about production grade Shiny apps, and of course some general design patterns that are, and this is my hint for you, that are all not only for object-oriented programming. And that is it from my side. We might have 30 seconds slot. I know that this might be too heavy, so we can have 30 seconds pause and we will go into mastering the implementation.
30 seconds are good, Pavel. Thanks. Just wanted to briefly give some breathing space, maybe for if there are any questions for this part, designing the solution.
I guess, are there questions in general from solution and what we have presented so far?
If not, it's also fine. Maybe you can grab a glass of water or coffee, depending on which time you are located. It's a long tutorial, so we have to be mindful of the biological limits.
Any questions? I mean, we try to answer questions on the chat, but if you want to get some clarification on no. Good. Should we move on then?
Okay. Then
So,
let's continue.
I'm going to continue sharing.
Yes, go ahead.
Good. So far it was, I mean, Teal heavy, but Teal really is more to show how did we approach the big thing. Should be also applicable to your problem that you're solving it. Oh, a moment, quick, I have to present, and then good. Right, that's good. Yeah, okay. Yes, so now it gets a little bit less Teal specific. Now it gets a little more generic. And the next thing is actually planning and design. So a lot about this presentation is plan and design your work before programming or at least once you've programming, reflect on what you have done, can it be simplified? And reactivity is a particular, I think, important area where it really is worth spending the time understanding your activity graphs and what do you expect the user interface does if you click on something or if you make certain interaction with the user interface. So generally working with Shiny, you don't get around reactivity. If you make the simplest of simple steps, yes, you don't have to understand reactivity. If you make a decently, if you add some complexity in user interactions, you do have to spend some time learning what is reactivity. The pitching carrier model is a great tutorial from our studio as well. It's just that you learn how to anticipate how will Shiny actually execute what seems to be magic. So we won't get into explaining reactivity, or I won't get into explaining reactivity more. I will more spend time on talking you through some things we have found very useful, which is summarized here. Keep the user interface simple, resolve reactive inputs early on, look at the reactivity graphs, don't have too many edges, don't interrupt reactivity. That's actually not sure if how many of you have got into that issue, but it's actually quite simple to do it. And we're going to show that as well. And then some general things we have found to be preferable with what type of observers and reactive conductors should be used. So if you make a user interface, and this is again similar to what is Teal before, but in general, you don't want to make reactivity such that when you change something, let's say you click on a button on the upper left corner, or a slider, that changes many aspects of the user interface. Because if you do that with one button, you likely do it with other widgets as well. And that becomes very, very hard for the end user to anticipate. Like even if it makes sense in a business context or an analysis context, there is a trade-off of does the user actually anticipate those changes? Because when you write the user interface, you also then, I mean, one thing is writing it, one thing is will your app user use the app as you have intended? The more complex you make your user interface, like the interactions, the more likely probably the answer is no. The end user probably doesn't use the user interface as you intended. Try not to make too many things change if you change a single widget. It's also error prone. I have spent debugging code in the wild that was with circularities. It was so complex that the logic, and it was also hard to understand what actually the initial author wanted to do with the reactivity. So the general guidance here is, or the general recommendation, keep it simple. Just make these absorbing states in here. The output is what, like, you have widgets to modify something, and here in this case in Teal it would be the output node. And so just look that when you change a widget, essentially goes directly into the output and not into any other parts of the user interface. That's simpler for you to program. It's simpler for the end user to anticipate what a particular action on the user interface will do. Now that said, there are certain expectations to these accessory expectation exceptions to that rule where you have to break that rule, but try to keep it as few times, like to do that as few times as possible. So I think while working on Teal, sometimes we had to not just make the output like the visualization of the table or the data frame in the center, the absorbing state or the observer essentially, but where one element modified also the state of another element. That's not a center output. Good. So that's the point one with reactivity. Point two with reactivity is right, like split your code up into different sections where first you resolve the reactive values. That like in one way it actually shows you what kind of reactive inputs or conductors trigger your observer, not the revaluation of render plot in that case. So here we know it's X var and Y var, changing those starts the render plot observer again, so updates the plot essentially. Then there's that handy function required that stops the evaluation if the X variable and Y variable are not yet defined. And then the next thing, which is very important, is that validate. Like I think be conservative in validation. It's better to more often say it doesn't work. The output probably doesn't create than throwing errors. And I think that's generally good guidance. Try to write a Shiny app where you never see a red error message, but rather the gray error message that come from validate, because validate propagates to the reactivity graph. So if you have a reactive element somewhere where there's an invalidation, like where essentially the validate doesn't pass, then it propagates down the whole reactivity graph and it doesn't evaluate anything downstream. So this is a very handy way to I think save compute time, to save confusion, and to show where did the error actually appear initially. And so, for example, this is something we ran enough, and not like if you run a linear regression, for example, and you have two data points. With one, I think it's obviously possible, but depending on how many variables you have, like add a couple of points more than is minimally needed, because anyway, how good would be the statistical analysis? You have to ask yourself now, like, at what point does the statistical analysis still make sense? And so this is your place to insert those validations. Just because you can do it doesn't mean you have to running a certain statistical analysis. And then the last piece, which Paul already mentioned before, is put the business logic not into the server code, put it into a function that is called within the server code. But also, if you resolve the values up here, you can actually, let me see, oh yes, that's what I've mentioned before. So I get back to what I wanted to say. So try to not have error messages. Yes, and if you do it this way, I've shown here with splitting it up, resolve, validate, then the business logic. It also makes it easier to debug. What you can essentially do is you can insert a stop, you assign your values into the global environment variables, and then you can add a stop in your Shiny execution, and then you can essentially go line by line, whatever comes after this, because everything then has nothing to do with the Shiny context anymore if you don't use particular scoping. And I think that's another thing. If you don't have to, don't scope into the server function. yeah, so, and of course that you have to delete that blue line here, but following this kind of pattern of developing shiny server functions, I think has proven to be quite useful for writing maintainable code. Good. So the next part is about reactivity graphs in general. So RStudio has that nice reactivity tutorial. Actually, they have multiple ones, but the one where they introduced the reactive source, reactive conductor, and reactive endpoint is listed here. There is a apologies. There's somebody. If you hear that, there's somebody making noise outside. So there is a tool called Reactlog, where you can actually visualize your reactivity graph, and it's quite simple. If you haven't seen that, I quick open the URL. You can essentially make a different app and give the app your Shiny app file name, and if you do that, if you run that, so here's where your Shiny app would live. It gives you a graph, and depending on the size of your Shiny app, that graph gets very big. If it's a small app, it's more manageable. But yes, very handy tool. Yes, and so the stringy part is visualized here. So when you look at your graph, it's maybe string is maybe not the best word, but I'll show why and call it stringy. But it's more like reduce the number of edges if possible. Like here, if this input modifies all three of those outputs, and this input modifies all of those, that adds a lot of complexity. If I change this, what exactly changes and why, and what's the common thing? So if you can try to make a reactive conductor that absorbs it and writes the business logic nice, or like that, or the user interface logic, not, and that's kind of the string, like try to keep the middle thin, like slim and long, not the graphs, and don't make these bulky graphs with many connections in between. That also becomes much easier to debug. And so, as I mentioned before, if you have a big, like if you look at Teal, the reactivity graph, it's huge. That becomes fairly quickly unmanageable. But try for yourself to understand what is your main reactivity. Like you have a filter panel, you have encodings, you have the output, and then try to plan, like just draw that out, abstract it, understand it. How does Shiny actually deal with that reactivity? How do you think Shiny does it? Try to test it in small isolated environments, and to see if your assumptions are correct, and then and then work, and then keep that main reactivity graph with the main logic consistent, and simplified if possible over time. So the next point is don't interrupt reactivity, and that's actually something we did in Teal at the beginning for the subsetting, and it had two things. Shiny actually is very clever. If you hide a certain element on the user interface, then the observers don't update. Like if the right hand side observer is a plot, but the plot is not displayed because it's in a certain tab, then it actually doesn't need to. Yeah, it invalidates, but it doesn't update the computation. So that's so essentially lazy evaluation in that context, and that's computationally quite efficient. Like for example, if a certain data set doesn't need to be filtered because it's not displayed anywhere, you don't have to go and filter that data set. And so we lost that for one, so that it slowed down the application, but also we lost the bookmarking feature because bookmarking does rely on understanding the flow of reactivity. And so that's that depends on how complex you design your Shiny app. I'll give you one where it probably doesn't interfere with bookmarking, but I would like to show you how simple it is to interrupt reactivity with that code here, and I've highlighted it in blue. So if you make a simple Shiny app where the UI has just a title, has a slider input that we call X, and in the main panel we show some text. Then that previous thing here, I think this is A, B, C, D, is that correct? Yes, A, B, D. It's actually, and then the output is the last one. So it's A, B, D, and then the output. And what we do is I just take a named vector and I double the last value, and give it a new name. So xval and then xval times ace. Then here you get a return value is a vector of a named vector with x equal xval, the slider input, then a is equal twice the slider input, and b is then twice of a, and so on. And so that works. And where we interrupt reactivity is here we make a reactive value. We make, so this thing here essentially is we make it like we make observe event of A, and then this here is isolated now, so nothing in here triggers reactivity. But we do change B, and B is a reactive value, so that would be that center, this one here in this case. And then the code block is that observe event. Is that observe event function body. Sorry, that body, those two lines here. Which when you actually look at the Shiny app, it perfectly works. It feels like it's completely reactive. It does as intended. But if you go and look at the React log, you see it's not a continuous reactivity graph. And so this is to show it's very simple to break reactivity as intended, interrupt, but make it appear reactive. And so be mindful of that. Try not to do it, because you lose certain nice side effects of what essentially RStudio builds around the reactivity features. Good, and then two side comments, or not side, but two things in general. When you find yourself in a situation where you can use either reactive or reactive values, try to use reactive, because reactive values you can modify on the spot. You can have multiple places adding more reactive value. It's just there are more pitfalls working with reactive values over reactive. And then with observe event, we have also found that observe event, when possible, is always better to use than observe with isolate, as a general rule of thumb. Good. And then here are some material on reactivity. There's also the Mastering Shiny book, which also has reactivity part, like information. But yes, and just especially read the Pigeon Carrier documentation in the Understanding Reactivity tutorial article. Okay, I hope that was useful. Let's see. Yeah, I hand it over to Paul then.
Yes, thank you. Let me share my screen again. I think we are on the track with the agenda, with the timings. So share the screen. Okay. So I will be talking. I hope you guys can see my screen. If not, please speak loudly. My part is about the so-called OOP in R in the Shiny app, because we found it pretty useful, and I'm gonna give you some hints how to efficiently do this, and so on and so forth. So first of all, quick recap. So OOP stands for Object-Oriented Programming. It used the concept of an object to manage the complexity of your program. Each object is an instance of a class. So class could be a person, and me, Paweł Rudzki, is an instance, and I'm the object of that class. Each of the object contains the data, those are fields, and the code or methods attached to them that are defined at the class level. So this is a very simple definition. A class is a person that has a name, surname, and birth date, and there are many instances of that class, many objects. We have Friedrich Chopin object and Nicole Kidman. Nicole Kidman, name Nicole, surname Kidman, and the birth date 20th of June. Happy birthday, Nicole. Key assumption of the OOP are the abstraction is to define abstract actors that can perform basic operation from the clients. There is encapsulation, which is building the data into the object. You can hide and prevent direct access or modification of some of the fields, and this is for the security reasons. Polymorphism is a single, in here this means a single interface of the objects of a different types. And there is an inheritance, so you can build some kind of structure that one class depends or extend the other one. This is so-called parent-child relationships between the objects. OOP in R, this is, first of all, there are many systems. System is a keyword. The very first one and the very basic is the S3. That was the very first OOP in R. It's frequently used throughout the base and stats package and the CRAN. This is probably the easiest system to learn, and my recommendation is to master it as soon as possible. As S4 is much more complex, strict, and rigorous compared to S3. It's popular for the bioconductor packages. So those are the packages that we are working with quite frequently. And it relies on the slots. Those are slots should be associated with the fields that I talked on my previous slides. And we are accessing those by the @ operator. The next one, the next system is R6, is the one that I like the most, is built or defined in the external package, R6 package. And the prominent attribute or the feature of that classes are that are mutable. Mutable means that you can change its fields, and this is not creating a new object, which is as opposed to the base copy on modify semantics. So the internal memory address of an object does not change on modification. This is critical actually for the reactive programming in Shiny, because Shiny reactivity is being identified by the change of the memory, most likely, and R6, as I said, does not change the memory address. Therefore, it does not trigger reactivity chain. This is something that we have learned down the way. There are some workarounds that I will present later on. There are other OOP systems implemented in R, such as R.oo, Proto, and today I discovered a new one, which is R7. You might change it into, you might find it on the GitHub, and I found it looking at the agenda of that conference. So looking forward for a talk. I don't remember when it's going to be held, but there will be a discussion about the R7 in user this year. And of course, see the great reference in the Advanced R book about each of this. Yeah, this is a great introduction, great overview of, apart from the manual of each of those packages. Okay, so I prepared some kind of very quick exercise, but I think that we don't have enough time to develop it on the fly here during during the tutorial. So I'm giving you a solution of the exercise. Daniel, if you may paste the GitHub link on the chat. So the task for this 15-20 minutes is to design an application to submit and store rates or votes or whatever we call it. And we have two types of the rates. Those are numeric, 1, 2, 3, 4, 5, up to 10, from 1 to 10, and the factor, which is great, medium, bad. And then at the end, we need to present some basic aggregative summary. We need to do this using S3, S4, as well as R6 OOP system implemented in R. So I'm gonna stop sharing and go into the code. Okay. Sorry, I should continue sharing, but I need to just switch the windows. Sorry. So I'm going to present my entire screen for a while to efficiently switch between the windows. I hope you can see this. So if you open the GitHub link that Daniel might kindly paste it into the chat, you might see the OOP directory, and there are many scripts. I would guide you to open the run one, run.r, and it's recursively sourcing all of the other scripts. So with this single call, you will have all the functions in your global environment. So very briefly, I'm setting up the R session. I hope it is readable for you. Let me just put it right. This is here. Okay, and run the app. Oh, come on. Okay, let me do it once again. Very well. So this is my numeric rates. I'm gonna pick it. For instance, I'm picking 8 and I click submit. This is the aggregative summary. This is a simple table on the array of the votes up until now. And this is the result of the str command on the collection. And I'm gonna click many, I'm gonna click this, and you see that it's changing. I'm gonna say 0 and the minimum 0. Okay, so it is all working, and you feel free to experiment with this. And let me now go to the presentation. Okay, so just to show off that it's all working, feel free to experiment on your own, because we don't have enough time to go into the code. But I will just highlight the most important parts. So the very first task is to, of course, design the overall system, right? So on this exercise, we'll be having some kind of interface class. This is some shared between the two alternative implementation. Those are implementation, this is interface, some kind of parent class. In the interface, we have the value, which could be here numeric or character. We have, just for the sake of this example, we have ID, and we have that should be unique. We have timestamp, and we have a method to extract the value, which is get value, and this will it will return the value that a given object store. So we have two alternative implementation of one interface. There's another interface of rate collector. This is so-called array of the list of the votes, as pointed here. On the very first field, we have rate, which is an array, I put it into brackets, of the rates. Oops, sorry. Note that it is rate, not numeric rate, not factor rate. That means that both implementation will fit that structure, will meet that condition. Oops, sorry. And again, ID of a collector and timestamp of the collector. We have also an add rate method to that collection, and get values that returns us the vector. You also see on the left and right line that this is a composite pattern, that the numeric rate consists of many numeric rates. Sorry, numeric rate collector. Actually, this should be a numeric rate collector on the bottom. Consists of many numeric rates, and factor rates collector is a collection of many factor rates. So how to create an instance? If you define the definition, then or if you define the class, how to create an instance, how to create an object out of the class. So in S3, you just simply call a function. In S4, you also call the function, but here this is a typical, let's say, recommended setup to have the factory, the object creator with the dot, and then goes the class name. And in R6, you need to use it $, and then a special method new, and some arguments. And then let me go into the code to show it here. I have so-called factory. This is a function that takes a type as an argument, S3, S4, R6, and depending on its value, I'm calling a function here, or this new method to initialize the object. Okay. Switching. I will be switching, so therefore I will continue without this full screen mode. Object class inheritance. So if we have, for instance, the S3 is nothing more than returning the structure, and then you need to have this special class argument that you give the vector of the class. And in order to maintain the class hierarchy, you need to manage by yourself. To, for instance, that the numeric one will run the top one, this interface that has the two classes in there, and then add one on the left, which takes the priority. So if I run the class to get the class of the object instance, I will have the vector of the classes. The vector is is pretty useful for some of the design patterns that I will be explaining in a minute. Same goes for the S4. The S4 inheritance is a little bit more mature or nicer, I would say. If we go into S4, I will need to create a class, rate collector S4. Then I'm creating numeric rate collector, and this is how I send the message from which numeric rate, maybe not rate collector. Let me open the rate. Rate S4 is much more simple. So this is a rate. This is a class rate. And the numeric rate inherits from the base rate. There is a rate S4 that is extension of the rate, and the numeric rate is extension of the rate S4. So this is how we build the structure. So then the object class inheritance of one particular object is as follows. For the R6, in order to build this vector, we need to define a basic interface in which we put two class names to have this rate also be present, and then the numeric rate. It's my mouse. Numeric rate inherit from that object, and that object is here. So this is how we establish this parent-child relationships, that numeric rate extends this base rate, R6 rate. And please also note that for R6, we have one additional value of R6. This is how R6 internally identifies that this is an object of the type R6. Okay, get value to access the slots. It's believe me, I'm skipping the code. This is done by $sign. For us, for S4, this is @sign, and for us R6, this is also a $sign here. For setters, the same, but please note that for us S4, this base assignment operator might be overwritten by some dedicated method. So for instance, your value might be taken from there and then further processed before it lands into the object field. And for R6, please note that the value might be a private field, so that you won't be able to access and further set this field, right? And I'm gonna give you some few object-oriented design patterns. First of all, the most basic is the factory method. Factory method is because those design patterns are being categorized. This is a creational design pattern that is providing some interface to create objects. And an example of this is our _factory scripts. So I have presented this. Factory is as follows. So those are the actual implementation or the object constructors, and the factory presents you the one single interface to create objects of the different, let's say, different classes basing on some, I don't know, environmental setting, or this can be even provided by the client, like in any way. Okay, this is for rate collectors, and for rate factory, we have the same thing, depending on the type. Okay, template method, another pretty useful one, is that you build some sort of skeleton in which you are modifying the only small parts of it. So an example is that in R6, we have rate R6, right? Rate R6. Please note that we have this initialize. Actually, that should point into initialize, which is the same because this is not being overwritten by the actual implementation of the numeric and factor. So therefore, if you call the new method, this code would be executed regardless if it's numeric or factor. Please note that this is some sort of steps, and the end one is validate, and the validate is being overwritten in the numeric and factor respectively. So there are two separate validation for numeric and factor, and we define a separate, let's say, we define the template in which we're replacing the implementation in the child classes. Okay. Oops, sorry. Another pattern is a composite. Is that this is a structural design pattern, which is nothing more than the one object consists of multiple objects, such as to build some sort of tree structures. And in order to perform some action, this action is being put into the child, and then child, let's say, carry over this to its child, and so on and so forth. So this whole tree collapses into one single or vector or object. But the whole thing is about processing and passing on the request to its child. And the method, the example is that I have a rate collector and I have get value. If you remember from my design slide, and this get value is being processed into the rate in some sort of for loops, and then extracted from rates and put it back into the collector. Facade is another one. Is to create some kind of simple interface to assume some to somehow hide some very complex and complicated and difficult to deal with interfaces to library, framework, or even some sort of classes. And an example is to have some sort of S3 dispatch in rate utils. So let me see. Yes, so this is a get value, and you don't actually know which classes you deal with. So I'm creating a function that makes use of the S3 dispatch, and then for S3 I'm running this $sign function, and for S4 I'm doing add function, and for R6 I'm doing again $sign. But me as a client, I don't really care which of the object I'm dealing with. I'm just wanting to have, I just want to have the values. So I have a special method, special functions that is being a facade overall complex, meaning this interfaces to a particular classes. Right? Another one. So this is a few examples, and I'm going to present mode here if I will find it. Slideshow. Okay, so the code is there, and feel free to experiment to see. This topic is very, very rich, and for sure I'm not gonna make it within this 20 or 15 minute slot. So I'm just giving you some hints how it looks like, and here are some takeaways of some summary of the OOP in our product. So first of all, S3 is the easiest to learn, and it's very useful, especially as a facade, as I presented you. My recommendation is to learn this as soon as possible, and I do recommend the connections between S4 and S3, as well as R6 and S3. Those combinations And I do not recommend going S3 only approach, because you might find this a little bit too simple for your use case. S4 has a pretty neat feature of multiple class inheritance. So this I haven't showed to you, but please trust me that it is. And it is about that class can inherit from two classes at once. And it resolves some, there is some logic behind resolving the conflicts of the method definition. This is not possible in R6 as well as in S3. Or you might find some very complex and not very easy to understand workarounds. Another neat feature is the multiple arguments dispatch. So if you call a function, you might have a different implementation of a method depending on the class of multiple arguments. In S3, for instance, the very basic one as I shown, this is single argument, the very first argument dispatch. So basing on the class, you might have different functions. For S3, we might use it for many arguments. Formal inheritance enables transparent extension. Okay, so this is pretty self-explanatory. Moving on. I personally found the R6 as the best one to maintain. It has very decent Roxygen support for class documentation, and moreover, all the methods of the class lives in one place, most likely one single script. It is a class definition. That is not true for S4 and S3, because it is technically possible to spread it across the files, and therefore you might find it quite difficult to maintain. I said also this at the very beginning, is that R6 blocks the reactivity because it's a mutate attribute. And then if you, for instance, set the rate or push the rate into the collector, then the Shiny does not recognize this as a reactivity trigger, and therefore for instance, your app needs to have some different logic up also from R6. There are some workarounds. So it is still possible to use R6 in Shiny, but the data slots needs to be a reactive value. And this is something that I have applied in my code, so feel free to check it out. So the value of the R6 rate is not, let's say, single numeric or single character. It is a reactive value. This has a significant disadvantage because assuming that R6 is a business logic is responsible of implementing the business logic, it tightly couples this into the Shiny, which is something that we don't want to have, as we pointed out earlier in that presentation. Here, my also pro tip is to be very careful with the scoping rules in Shiny, because you might find that the object is being created before the app is being called. So then that object is being mutated by multiple sessions at the same time. And that is an extremely situation where one user making some actions put this into the R6 class, and then this modifications is being visible by the other session. This is something that we don't want to have, and you need to be very, very careful. Also, a few takeaways as a general is that OOP together with the good implementation of the design patterns that I showed, could help you building some maintainable and scalable products. And here, good design matters. That's the keyword. If there is one sentence that you will take from this presentation, I would love to make it that one, is that good design matters. You might spend a lot of time on designing the solution, and that is time well spent. And the fun story is that when I was a junior programmer, and I was, let's say, working with some expert senior guy, I asked a question because this guy is like sitting in the front of the laptop, but the laptop was closed and just, thinking. And I was like, hey, what are you doing? And, he's programming in his head, he's designing. So the programming is not only typing the code on your keyboard, it's also designing, thinking how it's gonna look like. Please also note that there is no single and universal to your question. You might find that there are different answers, different implementation ideas. Each of this has its own pros and cons. And I tend to say to development teams that out of the 50 possible solutions, there are 5 that are good enough to proceed. And there is no single answer to a given question. When designing the solution, please also try to expect unexpected, or trying to anticipate changing the requirements, changing business context, all of it all together. Because the code that you are writing is about to last more than a week or more than a month. And within 1 month, you might face a different asks, and even you might not be maintaining this code, and that could be a different guy or different even team that will be maintaining. And yeah, please expect unexpected, and please put some, this O for the solid, which is closed for modifications and open for extensions. I know that it was short, but do not go blindly for a given pattern. Each of this has its own pros and cons. I would guide you for a manual. There is a great website, Design Guru, if I'm not mistaken. There's a great summary of a given pattern, where to use it, where not to use it, like where are the advantages or disadvantages. Yeah, that's true. You need to find the right balance and make appropriate assessment before implementing a given pattern. And my other takeaway is to not overcomplicate. This is a quote from the Zen of Python, is that simple is better than complex. Yeah, so summary of the overall implementation part, combining the outcomes of the OOP as well as the Shiny, is that few takeaways is to keep the UI as well as reactivity very simple and easy to understand, and trying to keep the reactivity graph as stringy as possible. Write good and clean and maintainable code. Avoid the code smells. Use the good objects, good patterns of creating maintainable code. Apply the design patterns if possible, and I would say if it makes sense. Do not overcomplicate, and apply the design patterns even if you don't use the object-oriented programming. However, all in all, this is not yet. We are not there yet. We need to make our Shiny product. We need to make Shiny product which is maintainable, understandable, and deployable. And the next section provides our experience on these critical topics. but we probably need some 1-minute break, right?
Yeah, thanks, Pavel. And also maybe let's give again space for some questions.
Yeah.
If there are any questions about the section, about the implementation section in particular. And thanks for staying so long, the people who stayed. So that's good. Well done, and we will have the last section now soon. So please feel free to speak up if you have any question. That's your chance to ask Pavel and Adrian, and yeah. Otherwise, we make maybe a small, 1 or 2 minutes break, so people can stretch their legs or something. Yes, thanks. Yeah, it's a lot of material. Yes. So that's why it's good that it will be it's recorded, and we can also rewatch this later and digest more and so on. Okay. Good. So I think we slowly continue again. Let me share my screen now. Okay, share. No. To a screen. Okay, can you see my screen?
Yes,
Yes.
it's there.
Okay, thanks. Very good. Okay, so last section here, packaging the product. And as mentioned before, why is this important? We still, even after designing the Shiny app and implementing it, there's still a lot of things we need to do in order that this nice little Shiny app package arrives, safely in the user hands, but also safely can be maintained in the future, can be changed according to different feature requests, or can be, hopefully not to have many bugs and so on. So that's the last section now. And this is basically what I now in a bit more detail. So basically tests are very important, and not just for normal R functions, but also for Shiny apps. And really the tests really ensure that the app works as intended in a reproducible way. And that's important when you change code of your Shiny app. That can be new fixes because there was some bug. It can also be new features and all of that. And again, of course, you need to realize in advance that you will always need to change your code, right? There will never be a time really when you can keep the same code over years. That basically just doesn't happen. And very important feature of the test is, of course, that you don't need to manually and randomly click around in the app and try it out if it still works and so on. Basically, the tests enable you to do that in an automated way. And that saves time, but it's also, of course, much more precise, and it's also much more, again, sustainable, because other developers in the future, they might not know maybe what was important, but the test tells them, okay, this should still work. So that in that sense, it's also much more sustainable. So that's tests. Documentation is also important. Of course, documentation ensures that you and other developers understand the code. it's a little bit maybe different here. I mean, the side comment here, right? It's a bit different here, documentation, than for normal R packages, because normal R packages are then directly used by R users, and they can directly look in the documentation, right? Shiny apps, usually you have a lot of users that are just, you know, using the app via a browser in an interactive way, and they might not interact at all with R code at all. So many users of your Shiny app might not see this documentation at all. But again, the important thing is it's not just the users that benefit from the documentation, but also developers, right? So it's important for yourself, because in the future you might not remember why, you know, this function or this module or something has this and this arguments, or what they mean, or how this all fits together. So maybe right now you still remember all of that, but in the future you might not remember that. And again, of course, the code needs to be maintained sustainably, so other developers might come in and they will be very grateful if you have documented the functions appropriately. And then last but not least, deployment. So that I will not mention so much about the last two here, documentation or deployment, but the focus will be on tests. But deployment is also, of course, needed, because in the end, okay, you develop this app, you packaged it, but you still need to deliver the app to the users, basically deploy it on a server. An important maybe prerequisite that we will mention is dependency management. So we will talk a little bit about that. And also just briefly mention, of course, there needs to be some kind of server infrastructure in place so that users can access the app in the browser remotely without starting R and, you know, starting the Shiny app from R directly. Right? I mean, this is kind of no-brainers here, but just to finish this end-to-end, you know, topic of how do we do a Shiny app in a kind of production-grade quality. Good, so let's start with the most important part here, the tests. So first of all, the motivation. Basically, it should be more fun for developers and users and less firefighting and bug fixing, right? So that's basically the main motivation. Why do we need tests? And in particular, if you're a user and you see something like this or like that, then you will get frustrated, and as a developer, you will get maybe some angry phone calls or chat messages. So we want to avoid this, right? So how do we do that? So we basically have a layered approach that is supported by the continuous integration infrastructure. So let's say the smallest building block here will be the unit tests. So what are unit tests? Unit tests ensure that a section of an application that is basically known as the unit meets its design. There we come back to the design topic from today, and behaves as intended, right? So it behaves as we wanted to it behave when we implemented it. And here, each R function, typically now here we're talking mostly about the static R functions for the unit tests. That is basically then tested separately, right? It can also be classes, of course, and the methods of the classes and so on. So we basically want to have small building blocks, and we want to be able to test each small building block with the unit tests. Now going to the specifics of Shiny, for basically the Shiny layer on top of our business logic, we have the UI functions and we have the server functions. And on the one hand, we can have separate Shiny UI tests. Basically, they just ensure that we don't accidentally change the UI, even though we don't want to change it. And the server tests, they can be also separate. They are much more important, and they basically can check that the server logic works as it should. So these are separate Shiny UI tests, separate Shiny server tests. And then, last but not least, we have this kind of integration layer on top of this, Shiny app tests. So Shiny app tests basically ensure that the UI and server and all the units underneath, they work well together, and they result in the intended app behavior overall. So we will look at all of this. And last but not least, the infrastructure on the bottom here that goes across all of these is the continuous integration. So that's basically running the tests automatically, for example, on GitHub, via GitHub Actions or GitLab, etc., and our other Git infrastructures. when we create a pull request, or or once per night or something, right? So this is very important, so that we are sure when we modify the code, every time we modify the code, we want to get feedback if all of the tests that are in place still pass, right? If I change the code and I see, oh, this test is failing suddenly, then I know, okay, and I did something wrong with my code change, so I need to first fix that and make the tests pass again before I can really merge this into the code base, right? So this is very, very important. And just a note, so we follow a flow here similar as in the Mastering Shiny book. There's a section on testing. So that's very recommended, very much recommended. And I will show a few practical tips and tricks with a few live examples, similar what Pavel and Adrian already did. And it's mainly to show that it's actually relatively easy to start writing Shiny tests. So nothing to be scared about, nothing to not like about it. Actually, it can be fun. So that's kind of the intention of these examples. Okay, but first of all, why should I actually write unit tests? Isn't that like a waste of time? No, it's very important, because it actually saves you a lot of hassle later, right? So it's kind of investing time now, avoiding trouble later. And what are the key benefits? Faster debugging, right? So when you have unit tests in place and you see one of them fails, then you know exactly, aha, only this little unit, there something is going wrong, right? And you can exactly zoom into this little unit, for example, function, and you can debug this function in your test case, and then you can very quickly understand what's the root cause, right? And think about how would this work if you just have the whole app and no tests at all. Then maybe something on the app fails, but you have no idea where in the whole app it failed, right? So that's much faster debugging if you have unit tests. And of course, because of this, you also can be much faster in your development, right? So if you have the confidence, because all of your tests pass, that there are no side bugs introduced from the new code or from your code change, that allows you to proceed much faster in the development. So that's also very, very important. Better design, as we heard from Pavel already, this good design matters, right? And here actually it's kind of interesting, because when you start writing unit tests, then you also notice, oh, maybe this function, maybe this class is too large, right? Maybe I cannot even write nice unit tests for that, right? So you are actually then encouraged to refactor this big thing into small maintainable units, get rid of this bloating code, right? Get nice small maintainable units, and then it's much more fun and much easier to write a unit test. So you get encouraged to do that. Better documentation. What do I mean by that? Basically, in addition to the actual documentation, which is, of course, we will come to that as well, that's also important. But as a developer, you can still also look at the unit tests to understand how the function can be used and how it should behave, right? So it's really also kind of a developer documentation of the stuff. Excellent regression tools, so that's also a very important habit. So every time you find a bug, right, we basically add a corresponding unit test so that it doesn't bite us again, right? So that's a very important habit. Otherwise, you might just fix it, and maybe another developer, another change later could then still come back to could still get the bug out, out of the hole again, and a bug would come out again or something, right? And we want to avoid that. So we always add a corresponding unit tests, and we are sure it doesn't come back. So last but not least, as a summary of all of this, reduce future costs, right? So writing unit tests is an investment that pays off long term, because bugs can be orders more expensive than testing, right? And that can be time for the users, but it can also be time for the developers. That is much more expensive. Okay, so just a quick reminder, many people will have seen this already, but what are unit tests in R packages? Basically, lots of examples and details in the R packages book, very much recommended. You can run, for example, use teststat in your package to get started. It basically sets up the package to use the teststat infrastructure. And the general structure is like this. You basically, for each unit test, you say teststat, Then you say, for example, oh, okay, my fun can do X, Y, Z as expected. And then you have your code block where you actually have the test definition. Typically, you prepare some inputs. Then you actually apply your function to do this X, Y, Z that you want to basically test. Then you hard code the expectation, and then you basically compare your expectation with the actual result, right? And there's many different variations on each of these steps, but in principle, that's kind of the structure. So the question then, when should I actually write these unit tests? So and actually, before we come maybe to the when, I think the most important change, you know, from a beginner programmer to a more advanced programmer is one of the most important changes, I think, is really considering the unit tests as being the same importance as the package code, as the same importance as the actual feature code, right? So basically, when you develop your Shiny app, it's the same. The energy and lines of code and you know, the complication you have with writing the package code, that's basically the same as you have for the test code, right? So they're more or less equal. It's not like that the features are more important than the tests. So when should you write a unit test? So there's one paradigm that says before you actually start coding the functionality, right? That's the test-driven development. I would say that's not really realistic when you start the package, you know, in the very beginning. But as you have already a package, or as you have your Shiny app already a little bit further, functionalities further, then it can be an option for adding new small features later, right? So it can be nice to say, okay, now I really want to achieve this. Okay, then you code tests for this thing, and then you write the code, and that typically works very well then. During coding, so when you develop new functions in R, you anyway need to do some kind of interactive testing, right? So typically you try it on a console, you see if it works, you come up with a little test case, right? So the idea is when you directly start writing the unit tests for doing that, that basically saves you development time already. Basically, you invest the same time as you would anyway have used, and you save time because you already put it in the unit test, so you don't need to write a unit test later. So this I would highly recommend. And then why is it important for the code review, for the pull requests, basically when your team members review your code? Because that having the tests in place that allows the reviewer to check the behavior of your functions without actually running any code themselves, right? So they can go, for example, on GitHub, they can look at the pull requests and they see, aha, okay, this and this were the new functionalities. Ah, this is the test. So here, so that is how it works, right? That is exactly the input, that's exactly the output. So they can give comments on that. Does it make sense? Or, you know, do we need some additional tests maybe to check this in this edge case? And then I mentioned this already before, when you find a bug, of course, then you also need to add unit tests. So basically you first reproduce the bug with a new unit test that can be basically like a reproducible example of the bug that can be turned very easily into a unit test. And this unit test, of course, will first fail, right? Because right now you want it to fail. You want to reproduce the problem. Then you fix the problem, right? And then you confirm that the corresponding unit tests, and of course, all other tests in your packages still pass, right? And then you're good. Then you're ready for your pull request to fix this bug. How do static Shiny UI tests work? So now it's a bit more specifically, you know, Shiny. Now let's first separately test the Shiny UI. Basically, the one thing we've seen here is you can snapshot basically the HTML code that is produced by the UI function. And why does it work? Because Shiny UI functions, they return Shiny tag objects, which is HTML code. And we can use snapshot tests to make sure that this HTML does not accidentally change. So there's a few more details in this link on the test stat documentation. But I would say the value is generally limited. And actually can create also issues because sometimes you get non-reproducible hashes. They're part of the HTML, and that can be difficult then to really make the tests, you know, reproducible. But in principle, this is how it works. So in principle, you can say, okay, similar structure as usual. So test that, for example, my input UI module creates expected HTML. you have some inputs. Again, you have some element that you make this thing reproducible. For example, you create some mock data sets. And then you say expect snapshot when you call basically your my input UI function with these inputs here from the top, right? This needs this needs basically tested 3.0 in the third edition, but otherwise this works. But again, I would say the value is limited, so not so important here. But of course, not so important to take the snapshot, but of course important to run the UI function and see that it works. I mean, that you can always do. Okay, so more important are the Shiny server tests. So this is really cool because you can really test the inner workings of the server function. Okay, how does it work? So look at this example. So we have test that server works, and then inside we have the block as usual. And now inside this test that we have test server. Okay. And test server is really where we now test our little server function here called server, right? And here we now actually have the whole thing happening, right? So let's go through this one by one. So the code provided is run now inside the server function. So this code here, right, which is in this curly brackets here, that's being run inside the server function, okay? So that's why we have this kind of double nesting here. We have a test stat for the usual unit test stuff, and then we have the actual test server here where we want to test inside the server this code, okay? And because we're running this inside the server, we can access everything inside the server function. So that includes reactives, outputs, and so on. So we can, for example, here say, aha, when we have been setting inputs in the session, then afterwards we can print what's the value of reactive 1. Or we can look at the value of this output 1 output, right? And really the session object is used to simulate the user actions. And we will come to that also in the limitations. If you want to do it interactively, you can also insert here this browser statement, and you can, of course, perform comparisons versus expected values as usual with test stat. Yeah, so I just mentioned. So the basic limitation here, or something to know, is you cannot really step now through this code interactively line by line as you might otherwise do it with your unit tests. But you need to insert the browser statement, and then you just run this whole thing. And then once you're in the browser, once you're in the server, your browser pops up, and then you can basically play around. This also works for module server functions. So normal server functions, but also module server functions. So there's a bit more details, again, in this mastering Shiny testing chapter on modules. And of course, you get the slides later with all the links, right? So let's have a quick look. So a quick example. So this is basically the same link as before, just now this different subdirectory. So let's go to the testing subdirectory now, and you can then later also do this maybe on your computer and try it out. So let's have a look at test server. Just have a quick look at the time. How we're doing with time. Okay, all good. Okay, so basically here, and I hope the font is big enough. I already made it bigger. Basically, we just need to start with Shiny. We have the latest version, and now we have a very simple app. Okay, so we have a UI here, and we have a server, and basically, let's see if this works. Okay. So basically what's just happening, we have here 3 inputs, x, y, z, and we do some calculation, like x minus y times z plus y. Okay, don't ask me why this calculation, but we just came up with this one. Okay, so it seems like we can play around with this and something is working, right? And of course, again, we could now play around with this every time we change code, and we could see if it still works, and we can calculate those results and so on. But that's, again, not very efficient. So that's why we go back now to our Studio. So, okay, we can stop this. So the important thing now is, sorry, first just a side comment and again on the UI. So UI actually in this case is not even a function, right? So here I have actually just a static UI, page definition. So it's not even a function. So it is actually this shiny tag object. And we could, for example, if we want to check that if we have a function that produces the UI object, we could, for example, see if that's a shiny tag list. We could check that, right? So this was just a side comment on the UI testing. So let's go to the server. That's the main focus here. So we wanna really try. Where's the server again? So we have the server basically here. So it's reasonably small, right? And actually, let me just quickly make sure. Did I pull the updates that I wanted to pull? Okay. Just quickly reload this again. Okay, good. So basically, we just do the calculation here: x minus y, z plus y. We multiply this, and then we run the text as the output. And now we wanna see if this actually works correctly. So now we can, for example, say, okay, let's jump into the server, and inside the server we can set the user inputs. For example, x and y and z all equal 1. And then, for example, we can look at what's the value of this xy reactive that we defined up here, right? And we can also look at the value of the output that we defined here, right? Okay, so let's just run this part. Okay, and you see we see some results here. We see some print statements being done, and that's exactly what we want. And why? Maybe just a quick reminder. Why do we need the session set inputs? Because inputs are not set at all, but there's no inputs basically in this test server thing, right? So when we say here, inside the server, just look at the value of these inputs that are there from the beginning. They're basically null, so it's nothing, right? That's also very important because we don't have, for example, it could be easy to think that we have 0, 1, and 2 as the default values, but we don't, right? Because the server is completely separate from the UI, and test server doesn't populate any inputs. So how would this now look like inside teststat? So inside teststat, again, we would have this additional wrapping with teststat as usual. For example, we could say, okay, teststat reactives and output updates as expected. And then we could, for example, say, okay, inside the server, we set the inputs and we check that, x, y has this result, y, z has this result, right? And then the output has this result, okay, and then we can run this, and that should be fine, right? Good. So this was test server in action. Okay, so what are the limitations of these shiny server tests? The one line is basically to remember it's not a full application, right? It's just a server. So in particular, the time does not advance automatically, right? So how could we work around this? So we could manually use the session elapse command to basically let the time elapse manually. As we just saw, there are no UI defaults used in the input values. Again, we saw the workaround. We can set it manually with the session set inputs command. There's no UI, obviously. Therefore, we can also, for example, not test if there are any UI updates that we actually wanted to trigger from the server, right? Sometimes we want to update some selection options from the server, and that's possible in Shiny, but we cannot test this, of course, with the test server here. Also, there will be no JavaScript run, because JavaScript is, again, just UI. Therefore, also need to keep in mind that showing notifications or any dialog boxes and so on, that doesn't work. Good. So therefore, that's basically the motivation. We need something else on top, right? So we have unit tests, we have UI tests, maybe we have the server tests. Now we come to the Shiny app tests, basically see as an integration test, does it all work together well? Does the app in the end work as expected? So the Shiny app test really simulate like a real user interaction with the app, right? So here I show you how it looks like with the Shiny test package. Just a note that there is meanwhile also Shiny test 2. That's a recent alternative package, and it seems to be better integrated with teststat. I have to be honest, I didn't try it out yet. I didn't try out yet Shiny test 2, but I was you know, happy to see that there is migration from Shiny test to Shiny test 2 is possible, and there's a little function in the package that makes that easy. So maybe have a look. But I think the principle still is the same. So how does it work with Shiny tests now? So usually, first of all, the app is defined in a directory. Let's say my app there, right? And there's an app.r file inside this directory. Okay. Then it's important to note that the Shiny driver is an R6 class, and we heard about R6 classes from Pavel before, so you're very aware of this still. And therefore, the methods are called with this dollar method name parenthesis syntax, right? That's why we have here app dollar screenshot, app dollar this, app dollar that, right? Because this app thing is an R6 object. And also, as we saw before, a new app instance is started with a constructor, Shiny driver $new. Okay. And what happens when we basically start up this, when we construct this new app object here, then really the full Shiny app is run in a browser, but the browser is headless, so it basically doesn't show up to us, right? Not like Chrome or Internet Explorer or something like that. But it includes everything. It includes the user interface, it includes updates of the user interface, it includes JavaScript, time, everything, right? And we can also look into the whole app or elements via text screenshot. That's also pretty cool. So we don't have like the constant kind of view on the app, but we can actually take screenshots either at the whole app or parts of the app by text screenshot. And of course, we can interact now with the app. So we can basically, with code, we can say programmatically define, okay, we want to set inputs, or we want to get values of inputs or outputs, or we want to click buttons, etc. Okay, so I would say for us in our experience, the value is high here because we can really store and code what a user would do during testing in a real browser, right? So it's really pretty realistic in that sense. I mean, of course, there's some stuff. I think it's still difficult to test the expectation. For example, I haven't figured out yet. Like, for example, how could I expect that a certain dialog? No, how could I expect that a certain notification pops up or something? That's probably still a bit, limitation. But in principle, all the normal interaction is really pretty well mapped to these to this code. Okay, so let's have a look at the second example here. So again, in the testing subdirectory, example 2. So let me go to our studio again. Okay, good. So first of all, so now we're here in this testing directory. Now we see here that we want to basically create a Shiny driver app based on the basic subdirectory. So we can first have at the basic subdirectory. So inside here we have a super simple application, and we can quickly run this to show that. So it basically just asks me my name, right? And then it says, "Hi, Daniel," for example. Right? So it's super simple. Okay, good. So far so good. That is the app we want to test. And again, of course, this is very much a toy example here, but the point is you might just want to test a single module, but you still need to wrap this in a very simple app that, for example, just shows the features of this module that you want to test, right? So you always need to come up with an app. Okay. Okay, so we load the Shiny test package, and we now construct this app object by calling the constructor. Oh, and you see this typically happens, so I think it's good to happen in a tutorial as well. So the point is, you need, of course, to be sure that this is really in the working directory. So we need to go to testing, and then we need to say, set as working directory, right? So in general, this is very, fragile with all this, where you are and what's the working directory and so on. Okay, so now it should work. Okay, good. And again, now we can do something, right? So remember, for example, as a user, maybe I want to type the name. Okay, how do I do this? I mean, first of all, of course, I need to look in the app code, what's actually the input field, what was the ID? Okay, here it's name, right? So that's why I use here set inputs and then I say name, right? So this, you still need to do this kind of transition. Then I want to get the value of greeting. Why do I want to do that? Because greeting, I know from here, for example, or from the server, that's the ID of my output, right? So that's a text output. Okay, so I want to get the value. And I see here, okay, hi Daniel, so that looks good. Then I want to click on this reset button, right? Again, I know from here, there's an action button reset. And we see here, upon clicking, we want to update the text input in name to empty string, right? Okay, so we click on reset. And then we look at the value of the greeting again. Oh, okay, now it's the empty string, that's good. And of course, at any time we can take a screenshot. It looks very small here. Just a quick trick, you can always then zoom in, right? And then it's reasonably sized. Okay. Okay, so let me close this. Good. So this was the basic usage, and now how to use this together with teststat. Basically, more or less the same. Why don't I have? Okay, I have the comparisons. Okay, so I don't show you here now the tested wrapper. The tested wrapper works as usual, nothing special about that. Okay, so you can always then say, okay, test that my app works as expected or something. But one important thing I wanted to show is that it's important to wait long enough. Okay, be patient. It's like with small kids. It's like with my son. I have to be patient with him, otherwise, I will scream too often. So. So when we set the inputs, if you have this really running in your CI/CD, in your continuous integration, it's important not just get the value, but you should actually wait for the value, okay? You should say, app, please, I want to wait for the value of greeting, and give a little hint that this is part of the output, right? And why is that? Because it might just take Shiny a while to update the greeting outputs, and if you just say get value, it might not yet be ready, right? And you might still get the old value, and then you might have a failed test, but it's just failed because you were impatient, right? And then, for example, now we can say, okay, now I'm comparing, right? I was waiting, I got the value, and now I'm comparing, and now it's okay, right? So I know, okay, this is identical to hi Daniel. Okay, so similar here. So now it's a bit even more difficult. So now I set name to Daniel. I waited for the value. It was hi Daniel. Now I'm setting an input to Ben. Okay, now I set the name to Ben. Now when I wait for the value, I actually need to say, please ignore the previous value. Okay, so the value 1 of greeting, I don't want to, I want to wait until this is something else, right? So greeting should change and it should no longer be the old value. That's kind of the logic, right? And that's what you want to do, because otherwise, when you just say this without specifying the old value as ignore, you might still just get hi Daniel back, right? Because this wait for value, the logic is it just normally just ignores nulls and empty strings, right? So if you want to ignore something else, some previous value, you need to specify it explicitly. Okay. And we learned all of this the hard way, I can tell you. So we had a lot of failed tests in the beginning, because we didn't do this. Then we can click on reset. Again, the same idea. So we can ignore now the value here, right? The value that we had here, and so on. Okay, now there comes a little thing. Okay, oops. So I reset it, but it's still not empty string. So something is wrong. So let's have a look at the value 3. What's the thing actually? Aha. So here, when we look at this, it looks like there was a validation. It was a validation error, right? So we can have a look at this. Why is that the case? Because here in our output of the greeting, we actually require a non-empty string, non-null name, right? So actually, in this case, we didn't even reach this part where we returned like a greeting random text here, but we were actually having this little validation error here, right? So that might also be very useful to catch, right? Because you might actually want to test that you are not then going into here, but that you are actually stopping here. And you can then test this with looking at this message, for example, right? You can, for example, say, okay, the message should be like this. You could actually check also the type that maybe you get this validation or shiny silent error here, right? Okay, so that's also possible. And of course, you can always take screenshots. If you're not sure what's happening, you can take a screenshot. Okay, it looks like this. Good, that's what we want. And also a small trick, when you don't know maybe what some input are called or output, or you just want to look what's currently all there, you can say get all values. And then you basically see all inputs and outputs that are currently there and what's the current value, right? Okay, and for help, there's a very good documentation in the Shiny driver page. This is basically the R6 documentation that Pavel mentioned before. It's very nice, everything together, right? Okay, good. Let's continue. Okay, some tips and limitations. So again, I just wanted to reiterate this. So wait long enough for everything, right? Be patient with the app. When you start up the app, when you construct the app, better increase the timeout arguments for the constructor. We have it on the previous slide. We have all of those increases of the timeout arguments. Inputs and outputs, use this app wait for value. Ignore the right values, that is the old or initial value. If that's not sufficient, you can also use, the syssleep command to just wait 1 second. This I would only use if it's really necessary, of course. How can you quickly get started with writing those tests? So there's a very nice function, record test, which you can use. We can basically run this on your app, and then you get a little. I will not do this now because it takes some time, but you can basically then click around and you basically record the actions that you do with the app, and then you get the code from that, and you can use it as a starting point. Especially for your first test, this might be very useful. Also, then later, the app get all values that I showed is very useful to see all available values. Also, the namespace function, use that to really make the code better readable. That's, of course, now relevant when you have modules. So, for example, you can first get the namespace for your specific module, and then you use the namespace, the lowercase 1 function to construct the name. So we will have a look at that in a second. Some limitations, you can only test the outside, right? So like a user, you can only test the inputs and the outputs. You cannot dive into the server functions to see what's going on inside. But of course, the server tests complement this, right? The test server function that we talked about earlier, that's complementing this. And it's also relatively slow. Also because you need to wait long enough for everything. So it can be relatively slow in terms of runtime. We have some additional tools available. You will get it later with the slides. So we have some helper functions for test. We have some extensions for Shiny driver on the GitHub page, which I think can be quite useful. Okay, let's look at the last example, testing the module. So I'm closing this again. Let's go to test module. And here you also see those increased timeouts, very important when you construct the app. And we're testing here something in module. So let's have a quick look at module. So module now contains here this part here, which are basically the definitions of the UI and server modules for histogram. And this is really copied from the Mastering Shiny book. And of course, normally this UI and server functions would normally be in the R folder of your package, right? So they would not be just standing here like that. But in principle, you have a UI function. So it's a function of your namespace ID. And then you basically, for example, do some, you have some inputs and some outputs here from that. Your server is again also a function of your namespace ID. And then you have this module server call here. Little homework here, if you want, you can improve this further by resolving the reactives first, as Adrian showed earlier, adding the validation and the requirements, right? But in principle, this is just doing a nice histogram here of this empty cars data set. And then you have the app. Again, even when you want to test your modules, you always need to wrap it in the app. So we have the simplest app that is possible. And then I would also recommend, for example, it makes sense then in your package, if you have modules, it makes sense to have a little sample app function that just starts up the app with the modules very, very simply, just that you just want to have a look at how does the module work, right? Because then once you have that in your package, you can just call here this app function and then you are done, right? Nothing anymore to do in this place. Okay. So this is how it works. So let's have a quick look at this app, just to show that what's happening. So we can choose your variables and bins, right? And this usually works, right? And then again, of course, we might have some problem, and this is where I'm saying there's a little homework. If you set the bins to nothing, then you have a problem, right? But okay, in general, it works. Good. Okay, so now let's look at how we test this. So here I'm wrapping this now in test that to show you the full thing. So we test that this module works. We load the Shiny test. We start here the application. Here's another trick. We can look at the debug log of the application. So maybe first let's just do this inside here. So what is this doing? Basically, the debug log is basically showing you more or less what will be shown in what's happening, basically, right? So we see, something is loaded, we're loading Shiny and so on. Now it's listing on a port, okay? Everything looks normal. Now here's the little namespace trick that I mentioned earlier, because in the app here, we use the hist1 ID, and this is using modules, therefore, we can use here the same thing as well. So we can see, okay, this is kind of the namespace function we need. So when we talk about bins, we can use that like this, right? So it's a namespace bins ID, right? And of course, namespace bins, it's just concatenating the name of the ID of the module with the ID of this value here, right? And again, for interactive development, I mentioned this before, taking screenshots, get our values, that's all very helpful. And then the nice thing is we can also take, of course, screenshots of specific elements, right? We can also say, well, we just want to have a screenshot of the histogram, right? And we actually get this little PNG file here saved to our directory. And these can also be compared. Some note of caution here that can be a little bit tricky, can be a little bit causing, let's say, failures on different platforms, because your computer might render this PNG slightly differently than your colleague's computer, than the CI system, the continuous integration system. So typically you want to skip those tests, those comparisons for equality of plot files when you're running it on continuous integration, for example, just to avoid the false failures, basically. Right? And again, here's how you would basically start from a record test. Okay, good. So almost finished now. Let's go to the end. So just a few words on the continuous integration. How do we set up this continuous integration? It's important to have it, but how do we do that? So there's a template available, github.com inside engineering R package template. So that's basically an R package template that includes GitHub action workflows and some tips in general. It's good to minimize, detailed formatting check problems on the server side, which are very annoying, because when you update your pull request and you get a linter error, or you update it again and you get a spelling error and so on. So you might want to minimize this back and forth on this little formatting thing. And here the pre-commit package, which allows to run pre-commit checks, is very, very useful. So highly recommended. Another tip, private repositories on GitHub will require payment for the minutes that you need, the CPU minutes you need for continuous integration, whereas open source repositories don't charge that. So another reason to go open source rather sooner than later. And stage dependencies is very helpful when working with orchestrated multiple packages, right? So when you have, for example, business logic in one package, Shiny layer in the other package. Yeah. So let's have, and that basically allows updating both packages in parallel. And let's have a little bit more detailed look at that, because it's, I think, pretty cool. So some details on stage dependencies. If anybody worked with a mono repository already, it's basically emulating that across multiple Git repositories. That's kind of the idea. And it's basically addressing the challenge if you have your functions split into multiple packages, but they depend on each other, then it might be difficult to add new changes. So for example, that's a concrete example here. So let's say we want to add a new feature, say feature XYZ in a package foo. But this requires upstream dependency update in the package bar, right? So think, for example, foo is your Shiny package, but it relies on bar doing the actual calculations, the business logic, right? And then maybe there's something else. Maybe we have the tests, integration tests. Maybe we have them in another downstream package called bus, right? So we want to do this here. We want to add this feature across these two packages, and integration tests here should not fail, right? So how do we actually do this? So the solution here can be stage dependencies with a branch naming convention, right? So here's again just an illustration of the situation. So we have foo here. Oh no, it's actually, sorry, no, it's actually the other way around. So foo should basically be, okay, now I'm not sure if I can change this now, but basically bar should be the business logic, right? So like this. Bar should be the business logic. Therefore, it's upstream of foo, and downstream we have this kind of testing package bus, let's say, right? So how does it work? How you can do this? So first of all, you can install a stage dependencies package and you get the link in the chat or later in the slides. And then you basically just use specific branch names, okay? So of course you use git, and then you say, okay, for package foo, right? My Shiny app, let's say, I use a branch name feature /XYZ. And for my upstream package, my business logic package, for example, bar, I use the same branch name, feature XYZ, okay? I don't need to have any branch specifically on bars, because bars, let's say, still runs the same tests as before, okay, to keep it simple, right? So then I don't need to have any specific branch, I just have the main branch. And stage dependencies will then basically see, when we want to run tests on foo or on bar, then it will basically look at the upstream and downstream packages, and it will see, if there is a branch name which is the same as my branch now, then it will check out that branch, right? and use the corresponding code to, for example, run your foo package, right? It will go and fetch the feature XYZ branch of bar, and it will run that together with your Shiny layer, you know, on front, on top, right? So that really allows to make this XYZ change across the bar and foo packages in parallel without breaking anything at any point, right? And if you want it, you can then also run the downstream integration tests on bus, right? So we found this super helpful when really working with these large applications that we really have code across different packages. Okay, so moving on to documentation. Some best practices. I mean, most of this may be boring for you, but therefore I will run relatively quickly through this. But basically, I would say it's almost as important as tests for the maintenance of the Shiny app package. So of course, you should have a README file. That's a quick entry point on the GitHub page. There's an example. I will not bore you with this now, but basically there's also a nice use this functions to set up an RMD README file. The news file is very important because it informs app developers, not the front-end users again, but the app developers of important changes. We also have examples of that, and there's also used this functionality for that. The vignette is important because it shows basically how the modules in the app can be configured. So again, all of this is more facing the developers, but still important. Yeah, maybe just clicking on this briefly. So this is another vignette. I wanted to look at something else. Okay, let's not look at this now. Okay, so use vignette from Eustace again sets you up quickly for that. Roxygen, of course, for the function classes and data in the package. That's most important for the future developers. I would recommend to try to document everything, including internal functions. And also try to use a consistent argument description, right? Consider including expected class. So what I mean by that, let's have a quick look here. So what I mean by that, we found it quite helpful to say, okay, this is your parameter, let's say object, and then you have like some convention on how you specify the class for this input, right? And this goes usually then hand in hand together with the assertions, right? Okay, generally we try not to assert everything that is just used downstream, but for example here, okay, flag violin, flag jitter, and we have this here accordingly, right? So this can be nice again for the developers later. And it can also be instructive and efficient to use central documentation pages with common arguments. So what does it mean? It means this add inherit params Roxygen tag can be quite useful. So for example, in the Hermes package, we have here argument convention file, which basically just contains standard arguments in their description, right? And then you can, first of all, keep more functions to using the same names and the same meaning of the arguments. And you can then just inherit the parameter description with this inherit params. Okay, also good to start using Markdown in Roxygen. There's also used this command for that. That's just a bit more efficient. Continuing this, last page of this laundry list. So lifecycle management is important because that allows you to phase out functions as deprecated later. Use lifecycle to get started. Package down documentation, that can be a nice user and developer resource in the browser, in particular the package API reference page. Again, there's a use this command to set this up. Developer guide, right? How could others contribute to the package? That's important if you have a larger team. That's also important. I think if you want to go open source or cross companies, I think that's nice. And can also be nice for the larger team internally. Yeah, so you can have a look later at this. There's also use this command for that. And last but not least, I think before releasing the package, it's also useful to take the user or maybe other developers' perspective and really read through the documentation pages. Does it make sense? Can you understand what it's saying? I think if you polish this, also, others will be grateful. Yeah, and what's not covered here, what I mentioned already earlier, so we didn't cover here like any kind of documentation for the or the only app users, right? We were talking here only about developers or users that would, you know, for example, app developers, as mentioned for the Teal example. So basically, people that still touching our code, still touching the code. I would say recorded video explanations, you know, or rollout presentations, you know, to explain people how does it work. That's probably more helpful than pop-up windows in the app. So we didn't go too much in this pop-up windows direction so far. Also, as mentioned, the validation checks that point the app user to inputs they need to change, and how to avoid, basically try to avoid red arrows from underlying static packages as much as you can. Basically, always try to let the user read a message that they can understand, and they can, for example, change the input. That's also very important. Okay, and last but not least, maybe it also would be nice to add some feedback or question buttons to your app to understand the problems, right? I think we also, you know, we will try this out a bit more, but in principle, you want to get some feedback from users. So you need to think about good ways to get that feedback. Okay, last but not least, deployments. Let's have a quick look at dependency management. First of all, how does the version system in R work? I mean, this is not so much new here, but the XYZ versions of packages correspond to the major version X. So those are breaking features. Minor version Y, that's our major improvements. And then there's patch version Z, bug fixes and minor improvements. That's generally the way packages are numbered, but I would say not many, you know, many packages are actually not following this semantic strictly. So that's important to keep in mind because, you know, you will depend on other packages, so you need to understand, you know, how the different versions, how do they differ. Minimum version, so if you depend on a package and you only have a 2-old version, then likely your app will fail. Therefore, it's important in the description of your Shiny app package to mention which minimum version of the packages you need, right? For example, deploy at least version 1.0. Just a quick note here, I don't think it's possible to actually request a specific version. So I haven't seen this yet. At least for R, you cannot do that. For R, you can only say minimum version. Less is more. Try to reduce dependencies. So maybe there's some fancy package with a short function. Instead of using that, calling that, you know, importing fancy package and so on. Maybe try to just do this functionality yourself, right? Sometimes this is much better. There's also this interesting tinyverse.org link, which has a few more ideas on this, and basically the key sentence to remember here is every dependency you add to your project, that's like an invitation to break your Shiny app, right? Because the more dependencies you have, the higher the likelihood anything of this will break, and then it will break your Shiny app. Deployment, so let's say given, you know, diligent dependency management, we really want to deploy our app, external versus internal here, so there's shinyapps.io. That allows for quick sharing of Shiny apps on the cloud. The free version, I think you can have like 5 Shiny apps, and it's good for quick tests or experiments. Serious use needs subscription for a cloud service. Then as an alternative, for example, RStudio Workbench server is an alternative that has more features. For example, can use environment variables and so on. And there's also a nice overview page which details the differences. Yeah, so basically this page. You can see all of the differences, and you see shinyapps.io has some features, and RStudio Connect or Workbench have many more features. Okay, good. So quick summary of the product packaging section. Tests are very important, super important, and ensure that the app works as intended. Use the unit tests for all the normal static functions as much as you can. Move as much code as you can into static functions. Make them small enough. add unit tests, very important. Use the server test to make sure the server functions work. Use Shiny tests to make sure the UI and the server work together correctly. Documentation ensures that you and other developers understand the code. There are many, many different facets to this, as you have seen from my laundry list, basically from news files to vignettes and so on. I would try to tick all the boxes, do all of that. It really will pay off long term again. And dependency management should be minimizing dependencies as much as possible. And I would really recommend using stage dependencies for the integration tests. Good, so that was the whirlwind tour of packaging the product. I will stop briefly here to see if there are any questions on this section. Where can I unshare? Oh, I don't know. Any questions on this section? Sorry, I don't know. How can I quickly unshare? Okay, maybe I go. Any questions? I see there was some question throughout. Okay, that's good. Okay. So there was a question. Let me see where the test stored. Let me see if I can manage this thing here. Thread. Where do you store the testing app for your module? Yeah, you would basically store that in your package, right? Let me quickly show this again. So I mean, here we're not in a package, but basically in principle you would have under tests, test that, you would have this kind of files, right? So instead of testing here, you would be in tests, test that, and you would have these files that do the tests, and then again you would have your subdirectories that contain the actual test apps that you need to basically wrap your modules and produce an app that you can actually test, right? So I hope that clarifies that. Okay, any other questions? Okay, thanks Elmar. Okay, good. So then let's quickly wrap up because it's also late already. So let me just go here to the wrap up. Not this one. This we had already. Okay, summary. So just a one-page summary, don't worry. So first of all, thanks for joining the tutorial. I hope it was informative, and I know there was a lot of material, and I'm sure you're gonna maybe look up some of this again if you're interested, want to try this out. And of course, we're happy about any feedback, you know, now or later. So what are the most important takeaways or to remember as headlines? You know, for designing the solution, it's like knowing your customer, right? Or KYC, I think was the acronym. So know your customer, talk with your customer. What do they need? What's the business context? You know, coming up with a good plan and a good, you know, objectives on this part is, I think, super important. You don't want to spend, you know, weeks and months or years of development and actually deliver a solution that nobody actually wants, right? So then when you know what solution you want or what's the objective, then I think having a nice architecture, layer-based, you know, a nice solid base, you know, as we've seen, for example, with Teal as a base, and then you have the Teal modules on top of that as layers, and Teal, of course, sits again on Shiny, so it's again a layered architecture. In general, you know, you have your business logic in a package, then you have your Shiny app in a package that's already also layered, right? So all of this layering and trying to separate the big pieces from each other, that's very important. And then scalability, so you want to be able to extend the thing later, so that's the kind of horizontal scaling, but you also want to customize your app, right? So that's kind of the vertical scaling. So that you want to enable that with your design. Okay, so once you have a design in place and you thought enough about that, then really the implementation, how do you master that? So keeping it simple is very important. So try to keep your UI interaction logic as simple as possible, as predictable as possible, so that the user doesn't get confused and you don't get confused either. And you can write tests that are actually easy to write. Then look at your reactivity graph, as Adrian showed very nicely, the tools and the thinking about that and how to really analyze this. Keep it stringy if possible, right? Avoid some kind of Mikado business, right? So that you don't want. And then of course, write good and clean code that will be easy to maintain. That's always important. Then packaging the product, as I just mentioned, tests are really as important as the features themselves, right? For me, that was a few years ago, that was the biggest learning when I realized, it's not just the code, it's also the tests, and they're equally weighted, right? And I would say that really makes the real difference for the maintenance, right? That really differentiates like a, average product from a really high quality product. Documentation, it's essential that you will have developers that can maintain the package code also in the future. Not just yourself now, maybe you are writing this stuff right now, but also in the future, this can be maintained. And then last but not least, deployment requires diligent dependency management. So rather keep those dependencies as minimal as you can. Good. Any last questions? Maybe any comment from Adrian and Pavel as well at the end?
So there is a question from Elma about if modules don't interact with each other, how should they communicate? So in Teal, the only communication that we needed is from the data filtering down to the modules. So essentially, we just made a top-down communication, but not in between at the leaves. Yes. So generally, you can do it. You can when you write the modules, you can make a return value from call module and work with that, pass it to the next module. But I would recommend be careful because then the growing and the scaling back and the growing the app is not so easy anymore. So we have managed to not make the modules talk to each other too much. So it's possible, but try to get your app without using it. I think that's the summary. Any other questions? I mean, as a summary note, I think my points here is like time spent planning is well, and analyzing, retrospecting the code is well spent time, and I think that's especially if you make big ones. Not if it's exploratory programming and you just need to make a point that it's possible, proof of concept, you can get by just writing something without planning. But that's once use, one throwaway, once use and then throw away product.
Maybe to add a few words to Elma's question is that our modules does not return anything. Those are only customers of the data. So from the module perspective, you get the data, you produce the outputs, which are presented within a module GUI interface, and that's it. You don't return, you don't modify the data. It has some negative consequences, such as we do have one use case where we have the outliers module, and we wanted to highlight or to create the flag from that module to be used then in the further analysis, but we decided to reject that request and keep the logic within the module and do not return anything. And the main reason is, as Adrian said, it keeps the logic simple, easy to understand, and also safe and easy to maintain. Because please note that if you have a lot of modules that, for instance, module A depends on module B, and for instance, it is technically possible if you release the package with both modules, it is possible to run only module B. What's the point then of keeping module A as a separate thing? Then you will probably need to extend module B to include module A functionality.
And so Elma also asked if the filter panel is a module. I think by now it is not, Pavel. And so
yes,
the difference is that the filter, like Teal, when it writes the user interface, it treats the module, the filter panel module, different than the analytics module. So the filter module is a more like a higher class module, I guess, or than analysis modules.
Yeah, and maybe also to add, I mean, let's say they're different. There are many different module layers in Teal and in your maybe Shiny application, right? And there are also modules within other modules, first of all, right? There are modules within modules, and those modules maybe on the smallest level, they might also communicate with each other, right? So that's not to say that we say modules should never communicate with each other, right? There was on a specific use case. It was decided at this and this level, it doesn't make sense to communicate with each other, the modules. But in principle, of course, Shiny modules can produce reactives, and they can be used by other modules, and then those kinds of things. That's still possible, right? Yeah, and they can also be very useful depending on the, where are we in the layering architecture, and that doesn't make sense, right?
And continuing the answer, from the technical perspective, how to establish the communication, the module needs to return. And the return value needs to be saved and then passed on to another module. There is some ugly way to do that, which I do not recommend, but I saw that. There is a session object in the Shiny programming, and there is a user data slot. So session $user data, in which you can push some data into this as a, let's say, treat it as a typical list, and then store the objects there. But I would not recommend that.
Any other questions or any other comments?
Doesn't seem to be the case. Okay, so thanks a lot, everyone. Thanks for staying so long with us. I've seen we lost a few people throughout the 3.5 hours, but that's understandable. So yeah, feel free to watch the recording again later, and yeah, please reach out if any further comments or questions or inputs.
There was a question about the slides, so we'll figure it out on this platform, but nevertheless we'll push the slides to GitHub repo.
Yeah, slides will be also available. Yes. Good. Thanks, everyone.
Great. Thank you very much for attending the tour.
Thank you very much.
Bye-bye.
Bye.